Bienvenue, welcome back here in the main amphitheater. I hope you had a great morning, and I'm sure that Guillaume's keynote was perfect. And yeah, as Nicholas already told you, we'll finally start with the on-site challenges, and for that we'll present you now the 5 challenges, and then we have a smart voting mechanism where you can over lunch express your preferences, and then the tool will automatically give you the best possible preferences according to that. We have all challenges filled, and all teams are more or less the same size. So yeah, Christian set up the tool, and he will quickly explain it to you.
Yeah, thanks, Marc-Oliver. So I will send around a mail soon, which will look like this one here. We have the 6 topics here of our challenges, and it's your task to copy that part between the dashes, fill out your priorities. So here's, for every challenge at the moment, there is a 1. Just fill it out, fitting to your preferences. So 1 is the highest priority, and then you can just go up to any number, like you can do it from 1 to 6 would be easiest. It's also possible to put a same priority to 2 or more topics. So if you can't decide, then you can set the 1 to multiple topics, or you can just leave it like that. Then it's like you don't have any preference there. Then copy this part into a file, storing it with the file name, last name, and given name, and upload it to the website where you also uploaded the PhD posters. The link will also be included within the mail.
So who understood how it works? Okay, 3 people, very good. So
perfect. So why?
Maybe I say it also once again. So your task is create an empty text file.
Yeah.
That is called last name _ given name.
Like.
Okay, first step. Second step, copy and paste this part with topics from the email Christian will send in a second. Copy it into the text file. And third step, if you are indifferent between all topics, you can leave it as it is, and you will get a topic assigned. If you want to give preferences to the topics, you have to change the numbers in front of each topic, and the topic that you are most interested in would be the 1, and then the second most interested, the 2, the third most interested, the 3, and like that you can express your preferences. You could probably even delete some lines or not.
Better not. So just
leave all lines, and if you have topics that you're absolutely not interested, just put them a 7, and then it's clear that you're not interested in those topics. Okay, how many people understood how it works? For those for whom it's not clear yet, which questions do you have? Okay, so and the important task is over lunch. So after our presentation, you have to do this. Otherwise, you will be assigned to a random challenge, which is also fine for us, but maybe you have some preferences.
So yeah, exactly. So if you don't submit a preference, we will just take it as it is. So every challenge will weight it equally. And if you have any questions, you can also respond or write to my mail. And tell me your question.
Or you can also just walk to Christian and talk to him. It's also possible. So there's a question. Maybe just go there with a microphone so that everybody hears it.
Thank you. I'm just asking, have we... do we send the email before lunch or after lunch?
Okay, that's also a very good question, because the idea is that you do not even send an email, but you use the same tool that we used for the posters, and you just upload your text file there. Christian will after lunch, so at which time will you do it? At now it's 12, so at 1:30 maybe?
Yeah, probably.
Or we can even do it live here in the end, and then we'll announce after lunch. We'll reconvene here again, and then we'll announce who's in which team. And that means you can do it after lunch. No worries about that. But like at the moment we are here, you should then send it.
Yes, yes, as Laurent is saying, the idea is that you can also use the lunchtime to discuss with the challenge manager, so you can know more, you can have more details, and then it's after lunch that you have to upload this file. You know, like before the end of the lunch, between the end of the lunch and the starting of the keynote.
And the good thing is there are no losers, because all challenges are super exciting, and therefore you cannot do a wrong vote, but you can just put like which are your preferences. And today we also have a camera kit, and now we see that it's working very good. And if you want to do it another day, feel free also to do it. We especially put it because some of the challenges will be presented outside, and therefore we also want to stream that. Good. So now it's clear how it works. Good. So this is how it works, and now to remind you again on all the challenges that we already presented, and as you see that there are lots of challenges that we did not present because they emerged to us at least today, which is great, so it's very dynamic. And so what I will do now is, as I was not aware of the numbering, I will present to you the C1 and the C6, and then Laurent will present something. I don't know which one he will present, but he will tell you. And for the other ones, it will be outside. So then afterwards we go outside, and there you saw already that there's a lot of stuff installed from the Camp OSV and from the SHIC probably, and therefore, yeah, we'll go outside, and there you hear more about it. So, but now let's start with the first topic. I already talked to you about it, but I structured it a little bit more. So the first topic. Do you want to present the hardware once again? Okay. So the first topic will be with Christian. So Christian will be the tutor that takes care of it. I'll also be happy to discuss with you, but he will be your main contact point. And so the first one is a hardware-software mashup with reverse engineering. So we have some cheap Chinese IoT devices, which are these lights here. And they are controllable via Bluetooth Low Energy with a proprietary protocol, and therefore we have to do some reverse engineering. The same stuff for a clock that has a countdown timer, which is helpful for informing speakers, for instance, about the remaining time, or when you present here your PhD challenge. This one is using infrared communication, again with the proprietary protocol, so this is also reverse engineering, even though we know how to reverse engineer both protocols, so don't worry about that, but this will be an interesting part of it. And the challenge will be also disassembling the hardware for looking a little bit inside. We already opened it together with Laurent some days ago, so you can have a look, and then you will create some gateways towards the different devices. You will create some logic, and yeah, so this is this challenge. And one result I want to have afterwards is this speaker. There you see it now. This speaker information system, where we have the remaining time for the speaker, so that when I stand here, I see, okay, I still have 10 minutes, and that the bars, I mean, you can think what you want to do with it, so you're totally free with it, so that the bars also indicate it somehow, so that I do not necessarily see only the time, but also maybe some colors. Okay. Are there questions to this challenge? If not, I switch to the next. So here you also see it again. The next challenge, which is the one that is listed last, so the Q6, I guess, this is live data analytics and processing. So we have the live streaming, as you know, and we already have a tool that is automatically taking screenshots. It's already quite cool. But the idea here is to look at live data. In this case, we'll have image data, and voice data and to do live data analytics, meaning more in detail that you look at the image data and you look at the voice, so you will use natural language processing to understand what is happening. And the goal here is to create a bot or multiple bots that are automatically filling social media channels. So that are creating like Instagram pictures or creating Twitter posts. And this will be very interesting to look at because it's to contextualize information and to find out how we can automatically create something. More details in the challenge. Okay, good. So these were the two challenges. And this challenge Lars is taken care of. And Erkin will also support both teams in the creation phase, and also later, where you will discuss a bit what you want to do and how you want to continue and so on. Because for the structuring, I would propose you, at least for these challenges, but also probably for the others, to start with making a concept. Where do you want to go? How do you want to distribute the tasks? And then afterwards, start full into it. For the timing, we have time today and also tomorrow, the full day, interrupted only by the two keynotes, and also tomorrow night. Okay, with that, Laurent, I would hand over to you. Yes. You want to present here? Okay, perfect. Okay, I thought the other one. Okay, perfect. Then I hand over to this Laurent, who has printed his slide directly on his t-shirt.
Yeah, so there is too many Laurent, so don't mistake. So we have the last sexy challenge because it's coding, but it's a way also to participate to the standardization process of a protocol that we described last time, which is called SHIC, for standard static context header compression. And we are here. So the name of the challenge is chicken because it's a very stupid joke about the acronym. And so we have this T-shirt, and we have also the eggs before the chicken. So what is SHIC, as I said last time, is a compression protocol that allows you to bring IP to very constrained IoT devices. And that's very important because this way you can manage the same way constrained devices and non-constrained devices. So it helps you to have a bigger Internet of Things. And so, as I said also last time, it's a standardization effort that has been done at the IETF. And we have some RFCs that describe the protocol, and we have implementation. And one of these implementation is OpenSHIC that has been developed during the standardization process. And what we proposed today is to extend this implementation to new protocols. And one of them is BACnet. BACnet is a protocol used in buildings to manage air conditioning and lighting or other stuff. So what we will have to do is to take some BACnet trace and do compression, describe new compression rules for this protocol and see the complexity if BACnet deals well with SHIC compression. And we are sure that it's the case, but we have to prove it. So I will not be here during the lunch, but Ivan will help you too.
So as Laurent said, hey, I'm Ivan. And if you have some questions, we can discuss during the lunch. And then we will see, hopefully we will see many of you on our challenge. Thank you.
Thank you very much. So the three other projects are linked with the Camp OSV, you know, this joint event that you saw the hardware outside. So I will let David present his project on the OSV, open source vehicle. And then once he has done it, we can go outside and see the hardware. And he will show you the hardware of his project, and then we will present you the two other projects of the Camp OSV outside. Okay? So David will speak in French, but then you can ask questions in English, or we can discuss, as said, during the lunch for the non-French speaker. Sorry for that.
Thank you. Merci. Bien. Je m'appelle David Levallois, je travaille pour l'ISTIC, qui regroupe l'électronique et l'informatique. Pour l'enseignement uniquement, de licence 1 à master 2, donc je passe beaucoup de temps sur tout ce qui est projet. Projet orienté surtout au système embarqué, qui est un peu plus ma spécialité. Vous m'entendez ? Donc la partie système embarqué est très implantée chez nous, l'électronique numérique plutôt. Et donc on a proposé beaucoup de projets depuis pas mal d'années orientés open source, en particulier des cartes que vous pouvez reconnaître qui sont très implantées dans la planète open source avec Arduino, Raspberry. C'est des projets que l'on voit dans beaucoup de projets d'étudiants, puisqu'on procède beaucoup par projet. Tous les ans, les étudiants ont leur propre projet. Donc la robotique, la domotique et les licences pro système embarqué chez nous sont des filières qui utilisent beaucoup d'objets connectés en fait. Donc là, le jour où l'IETR a acheté l'OSV, on a imaginé implanter des projets qui étaient déjà en particulier de la robotique beaucoup chez nous. Et donc, comme la filière licence pro système embarqué pour l'automobile et le transport était déjà bien ancrée chez nous depuis quelques années, on a proposé aux étudiants de développer des projets autour de l'OSV. Donc on a d'abord commencé à le faire sur table. Alors vous voyez ce genre de carte avec des objets connectés. Eh bien, on est dans l'électronique modulable, hein, des choses qui sont vues par les étudiants assez simples en travaux pratiques. Hein. Un ultrason, un capteur de lumière, voilà. Et on a de l'analogique et du numérique assez simple. Et on a voulu rajouter des éléments qui sont un peu plus complexes. Et pourquoi pas très proche de l'automobile, sur une maquette qui serait plug and play sur le véhicule. Le but était de pouvoir y mettre un projet, et l'OSV à la base était prévu pour que beaucoup de gens y mettent leurs idées sur l'OSV. Donc on met la maquette, on l'enlève et quelqu'un peut mettre autre chose à la place, quoi. Donc là je vais vous parler un peu plus architecture fonctionnelle d'un véhicule. Les véhicules sont faits comme ça, avec des bus de communication. On est dans le bus CAN, qui est très implanté et qui le reste encore aujourd'hui. Donc c'est un bus qui nous permet d'envoyer des données avec un identifiant et pourquoi pas avec des octets qui veulent dire quelque chose pour par exemple allumer des feux ou capter la vitesse du véhicule et des choses comme ça, avec des réseaux qui ont leur fonctionnalité. Et au cœur de tout ça, vous avez un boîtier de servitude intelligent. Alors je ne sais pas si vous voyez ce que voilà. Un boîtier de servitude intelligent qui est un OS qui est implanté avec un OS temps réel pour maîtriser le temps, pour maîtriser les données et la quantité de données dans un véhicule. Il faut maîtriser le temps. Alors voilà, je vais vous montrer juste un ou deux exemples. On a des boîtiers et chacun sont comme sur un véhicule actuel avec un calculateur et des données qui sont véhiculées via le bus de communication, le bus CAN. Là, en l'occurrence, on déverrouille notre maquette avec un tag RFID et un relais. Toutes les cartes sont alimentées de cette façon-là. Donc là, d'autres exemples avec des ultrasons pour le boîtier avant et des feux, la même chose pour l'arrière. Voilà. Donc ça, c'est implanté sur le véhicule, ça donne ce genre de choses. Et la maquette est dehors sur table. Et on a imaginé le mettre au point avec les exemples qu'il y a de projets. Alors on est en 2018-2019. S'inspire de ce qui existe dans l'automobile. Dans l'automobile, vous avez une application sur les nouveaux véhicules, et ce n'est plus un cadran aiguille, un combiné avec des aiguilles, vous avez une application, et le but c'était là, encadré par Ghislain Nouvel, qui fait partie de la plateforme Mobi, qui est plus orientée IoT et nouvelles technologies, c'est d'animer l'application en fonction de ce qui se passe. Avoir un effet de profondeur, avoir des informations qui interagissent avec l'utilisateur. Imaginez que quand vous roulez plus ou moins vite, vous allez avoir votre tableau de bord qui va s'ouvrir devant, l'image du tableau de bord qui va s'ouvrir avec la partie GPS au loin, et quand vous êtes en ville, ça s'approche. Et le but, c'est de récupérer les informations du véhicule et l'afficher sur votre tableau de bord sous forme d'application animée. Donc là, on utilise le langage C# avec le logiciel Unity. Donc le véhicule, la deuxième année, on l'a amené dans nos locaux et on a, avec les enseignants impliqués dans le projet, là j'ai oublié de les citer, Laurent Lebrisoil, qui est responsable de la plateforme Mobi, responsable de la licence Pro au système embarqué pour le transport automobile. Vous voyez là sur votre droite, c'est Damien Hardy, qui est enseignant à l'ISTIC et en informatique. Il enseigne la partie temps réel. Il y a aussi donc Ghislain Nouvel pour la partie IoT. Donc sur le véhicule, ça donne ce genre de choses. Donc vous voyez ici, on a un volant avec, on a possibilité de simuler sur table le fonctionnement de l'OSV, donc ou l'avoir directement sur l'OSV, ou comme c'est le cas dehors là, pouvoir faire comme si on était sur le véhicule réel. Donc là, c'était l'architecture fonctionnelle de l'année dernière. Je vais aller sur celle de cette année. Voilà, on a proposé cette architecture et ça s'approche de plus en plus à ce qu'il y a réellement dans un véhicule. Vous voyez au cœur, vous avez un boîtier de servitude intelligent et on communique via bus de communication entre un CAN primaire, ici, et un CAN secondaire. Donc là, dans un véhicule, vous avez ce genre d'informations qui sont véhiculées via le boîtier de servitude intelligent. Et vous avez des informations venant de l'OSV qui sont la vitesse, la température, l'angle volant. Vous avez différentes choses qui passent dans les bus de communication et qui permettent nous de faire fonctionner le véhicule comme un vrai. Donc là, les projets des étudiants qui seront là demain après-midi, on les a invités sur place parce qu'on a déplacé la maquette OSV. Ils viendront, les étudiants de licence pro, travailler sur leur projet. Donc, en l'occurrence, on a un projet qui est proposé pour instrumenter un peu plus le véhicule, pour faire un peu de sécurité et aussi pour faire évoluer l'interface écran, pour voir des choses qui sont en particulier pour l'infotainment, qui sont sur ce qu'on appelle l'écran multimédia. Le vrai terme, c'est l'infotainment. Donc on a ces données-là qui restaient à améliorer sur le projet de cette année. On a eu ces idées-là. Alors il y a aussi un lidar qui a été acheté par un des enseignants. Et ce lidar, il a la particularité de récupérer toutes les informations du véhicule avec la distance qu'il peut y avoir par rapport à un obstacle et de mettre en alerte le conducteur. Là, l'électronique embarquée, ça représente ça. Donc on a une Raspberry, un OS Raspbian, un shield de CAN, et le lidar envoie l'information au réseau pour ensuite l'afficher par l'intermédiaire d'un écran. De l'interface écran, l'intermédiaire d'une carte ESP32. Voilà. Donc là, il y a un autre projet qui est orienté plutôt temps réel et OBD. Alors l'OBD, c'est pour le diagnostic sur votre véhicule quand vous l'amenez au garage. Vous mettez la prise diag. Et donc le but, c'était d'associer les informations qu'on peut avoir à récupérer sur l'OBD et ce qui, pourquoi pas, pourrait être, dans les nouveaux véhicules, ils en parlent de plus en plus, une boîte noire. Donc quelque chose d'assez simple pour récupérer les informations qui auraient pu être un danger imminent, pourquoi pas, et donc qu'est-ce qui s'est passé dans les secondes qui précèdent. Voilà, donc là, pour la partie temps réel, ça fait ce genre de choses sur lesquelles les étudiants travaillent déjà depuis 2 ou 3 semaines. Voilà, alors l'objectif de ce projet-là, qui était orienté camp OSV, c'était d'abord de montrer ce qu'on peut faire avec un véhicule, mais aussi vous suggérer, pourquoi pas, une collaboration avec l'Internet des objets, et en particulier tout ce qui est cybersécurité. De plus en plus, c'est un sujet qui revient dans l'automobile. Et en particulier, alors je vais revenir sur cette partie-là. En fait, vous avez deux cartes qui sont des objets connectés. Vous avez, enfin 3, puisqu'il y a 2 Raspberry qui sont connectés en Wi-Fi ou Bluetooth et sur lesquels vous pourriez, pourquoi pas, vous connecter et pouvoir envoyer des données sur le véhicule et changer des choses pour interagir de façon pour hacker, pourquoi pas, le véhicule, quoi. Donc là, si vous avez des connaissances en communication Wi-Fi comment dire, dans les objets connectés et l'Internet des objets, vous pourriez imaginer accéder à la Raspberry à distance ou le SP32 qui fait du Wi-Fi aussi et venir interagir avec le véhicule. Voilà, c'est une faille qui n'est toujours pas résolue à mon avis, parce que c'est des sujets qu'on entend régulièrement, en particulier sur l'infotainment, qui est un OS, et souvent c'est du Linux. Si on arrive à se connecter à cet OS-là, on peut hacker le véhicule. Donc c'est des choses qui restent à faire d'un point de vue cybersécurité. Voilà. Merci.
Super, merci beaucoup. And for the English-speaking people, with this project you can revolutionize electric vehicles and also take care of cybersecurity. No, it was much more in detail, of course, but I hope that you could follow a little bit the presentation. Good. And for the other presentations, we'll now go outside. They will be presented there, and then directly afterwards we'll go for lunch. As usual, you can keep your computers here. We'll lock the room, and then after lunch we'll come back here into the amphitheater, and then we'll tell you something about the presentation of the projects on Friday and about how we will continue. So yeah, now let's enjoy the next 3 presentations, and then let's have lunch together, and then see you all again in here, probably 1:30. But as we'll all be all together, we'll also see them.
Okay, I'll give you a quick explanation of this. This is a personal project I built in my garage. It's a recumbent bicycle, so it's got 3 wheels with the pedals inside, so you can pedal, and it has an electric motor in the front wheel. And a simple, it's basically a kit that you can buy online to electrify the vehicle. So it's kind of decorated as a Batmobile for fun, and the idea is to see how maybe we can make some IoT to improve the security. So at the moment we've just got flashing lights for turning lights and a front light, and then rear lights, but nothing is automated, and just got one rear mirror. So the idea for this project, but obviously you can participate and give your ideas as well, but we could perhaps start from a small ESP32 based screen, and maybe work together to make some kind of icons, so we could have to improve the security for the person driving, have different alert icons which could be displayed on the dashboard, which is inside, at different critical moments. So that would be one idea for people to get agreement on how we could define simple protocol or architecture, very simple, and we could add some sensors to it. I've got some LiDAR modules, for example, I could bring, and we could maybe use any other kind of sensors connected to this to improve the security of the vehicle. I'm working for Orange in research on mobility, and we're interested in using 5G to improve the security of people traveling in different types of vehicles. So this is kind of a personal project, but it's kind of linked to my actual work. And so all aspects of improving security of moving vehicles are interesting to us. And as Orange, we have obviously 5G, the 5G network, which is being deployed. These are research questions which I'm interested in my research project. And this is kind of one of the vehicles which you're probably going to see more of, maybe not as a Batmobile, but more vehicles we will see with people traveling to work in different types of vehicles. So yeah, it's a research question that I'm interested in, and maybe for this 3 days, if you're interested to join this workshop with Baptiste, who will also be with me, because I won't be here all 3 days because I'm working just across the road. So there you go. That's the proposition, is to think together on this or some other simple device for alerting on events to improve the security of the driver. Thank you.
So hello everyone, I'm going to present this workshop. So it's referred to in the document you were given as a BMS, Battery Management System. I'm not only working on this. The elements you can see here are the elements you need to move an electric vehicle, and all this is called powertrain. So here you have a 3-phase motor, and to spin this you need a board that's an engine controller, this board, that will convert the DC voltage of the battery to AC voltage. And this board I made is actually derived from open hardware and free software project that you can find online. That's called VSC. And on the other side, you need a battery. So I don't have an actual battery, but we are faking it with this power supply here. And there is also this board that I made, that's a battery management system. This is what I'm working on currently, and I've been working on with the compositing community for actually quite some years now. And this is a work in progress, so I was inspired by this project to make this one. So this is supposed to be monitored to monitor a 12 cells battery. And there is a lot of things that's not working yet on this. So one of the ideas could be to continue writing the software, making it work. We can talk how to make a good BMS. I already have elements about this. Also, the two boards implement canvas, so we could see how to make the two communicate like they would in a real vehicle. Also, I never tested this motor. I only tried this board with a small motor that I have somewhere, but it never mind. So one of the things we could do would be to test this motor. The VSC project comes with configuration software, so yeah, we could see how to make this and this work together. So yeah, this is it. Thank you.
Bah, je sais pas, ça dépend. Maybe, okay. Maybe we can present a side project. It's about mobility. It's to explore a new way. I don't know if it's a new way because it's with our student, and we just explore a light way to displace things. Maybe you have in your life the possibility to run your car, but it's heavy and it takes a lot of energy. Maybe your bike is cool, but you can't carry a lot of things, and maybe you can't pedal neither. So we explore this scooter, but a cargo scooter, so you can put here some boxes, or your child. I made some design. So it's light, so it took not so much. It takes not so much energy, and everybody can carry things, because maybe you don't have children yet, and maybe you don't have a family with a lot of grocery to carry every day, but this is the project.
Lunch break?
Oui, je sais pas si David, tu voulais rajouter quelque chose par rapport à la plateforme ou pas, tu veux. En français.
Did you understand this platform? Same or not?
Yes, that's French.
Okay. So basically, some professors at ISTIC have developed this system, which is a way of making a CAN bus like you have in a vehicle, using Arduino, Raspberry Pi, and different simple electronics that you know in your studies. So it's a way of allowing students to interface with the CAN bus and send information and receive information as if it was in a real vehicle, but using open source solutions. And so all the electronics here is using CAN bus interfaces on Arduinos, Raspberry Pis. There's an infotainment screen with a Raspberry Pi, and you have several different buses, internal buses communicating to enable the system to work. Okay.
Nice.
What is the objective of the challenge? So,
To communicate with the OSB and simulate, if you want, to change things, lights, for example, or change information, like the angle of the direction, or why not put on the brake to see and replace the good functionality.
je parle français, mais c'est surtout pour les autres. Mais
Okay.
si vous voulez répondre pour moi en français, ça ne me pose pas de problème.
If you put on for example, the Raspberry Pi or the ESP, you can change things de la distance, for example, by Wi-Fi. Over the air.
It means that right now, if you hack the system because it's not well secured, with your smartphone, for example, you can enter the system and then send commands to more or less everything in the car.
Okay.
So one aspect is to study this and to see how the communication network is working between the different elements, and to be able to secure this protocol. Let's go for lunch. Yes. On va mettre dans la salle du fond.
I love this. Do you go to like? I zoom in the desert.
Yeah, but it's good. I just had the idea that because it's perfect.
Is this mechanic?